Hello there, and then welcome to a brand new video. This is Happy Beyond Numbers, where we learn maths the easy way. Now, in this lesson, we are looking at interpreting travel time or the distance time graph. And by the end of it, you should be able to accurately interpret the distance time graph and then answer word questions based on these graphs as well. So, without much ado, let's quickly look into it. Now, you should know that the distance time graph is a graph that shows how far something travels over time. Okay, so anytime we are looking at some keywords here before we start the question. So anytime we say a body is stationary, then it simply means there's no movement going on, and we represent it with a horizontal line. And anytime we say there's a constant speed, then it simply means that there's a straight diagonal line that we can use to represent that. You see, and it can either be up or down. Now the return journey is for when the line slopes back down towards the distance 0. That is where we use the return journey. And the gradient usually is the steepness of the line, how steep the line is. So to calculate the speed from the distance time graph, which is also sometimes the gradient at the point, it is the distance over time. Take note, it was the vice versa earlier on and I had to change it. So it's the distance over the time. So with these keywords and then vocabularies, let's quickly look at some questions and then see how we can apply them. So in this first question here, it says, a boy leaves home and walks to the park 3 kilometers away in 30 minutes. Now he rests at the park for 20 minutes and returns home in 40 minutes. What is the total distance traveled? And then how long was the total journey? What was his speed when going to the park? And then what is his average speed for the whole trip? So to answer the question, we need our graph sheet. And as you can see, I have labeled my axis nicely. Okay. So on my distance axis, I have from 1 to 4, and then which is in kilometers. And then on my, what do you call it? My time axis, I have from what? 0 to what? 90. Now let's try and interpret this on the graph. The first part, as we read, says the boy left the house and then he walked to the park. The park is 30 kilometers away and he did that in 30 minutes. So you come to your graph and locate your 30 kilometers. So these are 30 kilometers. This is the line that represents what? 30 kilometers. And what line represents 30 minutes? This is the line that represents 30 minutes. You see? So you look for their point of intersection and then we'll draw the straight line to represent that travel. You see? So I'll go for my ruler and then just draw the straight line 30 and then what? 3. With that done, we go to the next part of the story, which says he rests at the park for 20 good minutes. 20 minutes. We said that when there's a rest, the distance does not increase, neither does it decrease, but just what? A horizontal path. So we know per our scale, or the scale I'm using here, that for every 2 boxes, there is a what? 10-minute interval. So for 20 minutes, it is going to end over here. You see that? Then we go to the next part of the story that says he returns home in 40 minutes. In 40 minutes. So if he returned home in 40 minutes, then we know his point or his location now. This is it. And he's going to return home in 40 minutes. Now he's returning back to his starting point. So that is going to be what? Downwards. There's no more increasing in distance, but then he's going back to his starting point. And he does that in what? 40 minutes. So we know if this is the initial time that he was at, this is plus 10 minutes, plus 20 minutes, plus 30, and then this comes to be our 40. You see, if we look at our story, there's nothing else to what? Draw. Hence, that here is the representation of the travel of the boy. Now we look at it carefully and then answer the questions that follow. And I would advise you really pay attention. It says, what is the total distance traveled? If you want the total distance traveled, all you need to do is to add the diagonals, the distance of the diagonals, because we know for the horizontal, it is always a point of rest and there's no distance traveled. You see, so we look for the distance of this diagonal and then the distance that this diagonal also would represent. And if you look at it carefully, from his home to the park, this was the park, was 3 kilometers. You see, now from the park as well, back here is also 3 kilometers, which is represented by this you have over here. You see, so we say that the total distance traveled will be the distance to the park plus the distance back to his house. And as we have looked at, that is the 3 kilometers plus 3 kilometers, which then gives us a 6 kilometers. So the total distance traveled is what? 6 kilometers. Let's look at our second question. So the next question says, how long was the total journey? How long was the total journey? Talking of how long, they will mean the total time taken for what? The journey. And how are we going to get that? So if you look at our graph over here, you see that there was a time taken to reach this 3 kilometer distance here, and that was 30 minutes. Now he has also rested per our scale for how many minutes? That is 20 minutes. And then the time he took back to his initial destination, that was also a 40 minutes. You see, so to answer that question, we are going to say that the time taken for the total journey is then going to be what? The time taken to the park. Then we add that to what? The rest time. Then we also add that to what? His return time. You see, and looking at that, we said to the park he needed or he took 30 minutes. And he rested for what? A 20 minutes. And then finally it took 40 minutes to return. Hence, the total time taken will be what? A 90 minutes. You see, or in hours, that is just 1 hour 30 minutes. That is 1.5 hours. You see that? Yes. So this is it for the second question. Looking at our next question here, it says, what was his speed when going to the park? What was his speed when going to the park? So for his speed when going to the park, they mean the speed for this particular one over here. You see, and initially we said the speed is what? Distance over time taken. So if you want the distance or the speed, sorry, for this one here, then we are going to divide the distance he covered by the time he took to cover that distance. So we'll say the speed when going to the park is then going to be what? So we know speed is equal to the distance over the time. You see, and we said the distance he covered when going to the park was what? 3. And the speed is what? 30 minutes. And 30 minutes is just 0.5 hours. You see, we want to change it into hours because we are actually working in kilometers. So kilometer per hour, you see, that is more appropriate than per minute. So we have 0.5 hours. And simplifying further, we have a 3 divided by 0.5 is just the same as 3 divided by 1 over 2, which then becomes 3 times 2 over 1. You see, and that gives us a 6 kilometers per hour as our speed when going to the park. So this is actually his speed when he was going to the park. Now let's look at our last question. The last question says, what is his average speed for the whole trip? What is his average speed for the whole trip? So when we talk of average speed, then we mean the total distance over the total time. The total distance over the total time. And if we come here and then we look at the total distance, then the total distance he has traveled, which we even solved it over here, is what? 6 kilometers. You see? And then the total time we have also solved for is what? 1.5 hours. You see? So to solve for the average speed, you're going to say the average speed is then equal to what? The total distance. So our total distance all over the total time taken. And we earlier on solved the total distance to be 6. And then the total time was then what? 1.5, which when you simplify it gives you a 4. So 4 kilometers per hour. This here is our average speed. This has been such a very long video, and I'll leave out some exercises for you to try just to test your understanding. So here are some exercises you can try on your own just to test your understanding. They are just basic ones, and I do hope that if you really understood what you did, you'd be able to approach them as well. This is how beyond numbers where we learn maths the easy way. You can always let me know at the comment section of any issue of concern. If this is your first time, you can always choose to subscribe. That is if you so do wish. So that anytime I release a video, you'll be notified as well. Thanks for staying tuned. Bye, and then see you in our next lesson.